Okay, welcome to today's class. So as always, let's start with the syllabus. We are here. We are April 30th. This is the penultimate class, the penultimate lecture. Today will be a quiz, as you all know. If anybody has not gotten your quiz sheet, please get it from the back. Woohoo! Are we excited? Nah. All right. So what are your questions? You're going to have a quiz today. You're going to have a final exam next week. This is your chance to focus in on the things that most worry you about this course. And maybe that, yes.
On the syntax of generics and stuff.
Okay. So let's briefly go over the syntax of generics. It's that time of year, I guess. All right, so let's take a look at what we got here. Let's look at wildcard. Okay, wildcard is the hardest one, and so maybe it's like the worst one to look. Well, let's not look at that one first. That's kind of the worst one. Let's look at generic array list. Okay, generic array list. The idea is when you have a class and you want to use a generic type, right? You put it on the class name inside angle brackets, right? And then anytime you want to use that, use a generic type, you include, whatever generic types you have. That's the easy part, right? And then anywhere you want to put that generic type, you just use it as if it were a type. So in the case, if I'm writing an array list, I want to add things of type. I have my generic type of V. I want to add things of type V. So I put a V there. If I do a get, then I'm going to return something of type V. And that keeps everything consistent. It means I can only, the things that go in and out are always of type V. Okay, so that's the simple thing. And here's I have my iterator. My iterator is going to be over things of type V. So I can return the iterator of type new iterator type V. And then I have my has next, and my next method returns V. Okay, now the tricky part is that generics are by erasure, which means that the compiler cannot instantiate new V array. And because of that, I have to use object instead, right? And object instead means I have a couple of complexities to worry about. While an object is the base class of any class, and so it's perfectly usable to store anything I want to store, I have to make sure that going in and out, I have the types checked. Now for add, that's easy. It's just by default, right? I can just assign things of type V to a type of something of type object. But for a get, I'm in an awful situation in that I have to cast it to type V. Now the compiler lets me do this, but even though it doesn't know what type V is, except at compile time, but it produces a warning. And so I have to put this silly little suppress warnings unchecked thing on if I don't want to look at the warning. But there's no way to avoid the warning. So there's that. Any questions? Yes.
So that warning happens because it doesn't register the generics at
Right. So what happens is the warning tells me that I'm doing a cast without doing an instance of check, which is potentially unsafe. But it won't let me do an instance of check because it doesn't know the type of V.
Right.
So it's a catch-22. I lose either way. So the best I can do is suppress the warning. Okay, now if I have a generic where's the thing I want? Generic tree map. Okay, generic tree map is a little bit special, right? Because what I want to do on the generic tree map is I want to, what I want to do in the generic tree map is I want to have the things in my map, I want the keys to be comparable. And java.lang.objects does not implement the comparable interface by default. So it's not, I can't use just anything. And so I have to specify, when I specify my generic type, that I want a generic type that allows me to compare it with itself, right? And the way to do that is inside the angle bracket, I can say K extends comparable K. And I can do that on the declaration of the class, right? I can put that on the declaration of the class, but, and once I've done that, then anywhere within the class that I want to call compare to, I can, right? Follow that? So if I didn't need to call compare to, I wouldn't need that. And so the generic tree node, for example, when I declare that one, it's just K and V, because inside the generic tree node, I'm not actually doing a comparison, so I don't need that. All right, I mean, I could put that there. It probably wouldn't prevent me from compiling or anything, but I don't need it. Got that? Yes.
So you can't call compare to because,
Right. It doesn't have the key K extends comparable K. I wouldn't put it on V. That's the value. It's the key I would want to compare in a map. Because I don't sort based on the value in a map. I sort based on the key. That's why it's called the key. Does that make sense to everybody? Okay. So, I mean, I currently can't do that in here, but on the other hand, I don't do it. So it's not a problem. The place where I do it is in the generic tree map, at least the way I've written things, right? So, so I need it here. I don't need to repeat it on the node because it isn't used in the node. But anyway, the compiler has to be able to check that before I use a compare to, I have something that is in fact comparable. Any questions? All right. Did you pick up Ty? Ty? Did you pick up a bubble sheet? Ty? All right. Let's look at wildcard. All right. So in wildcard, we have, you know, the gnarly details, right? We have the possibility of using question mark as a type instead of object. And question mark means that I can accept a list of anything here, whereas this one requires specifically a list of object. It won't let me take something that subclasses object. It requires list of object. So this is more generic code. Okay. Now let's look at copy. So this copy method takes a generic type, but it's a static method. So if you're going to do a static, right, the generic declaration goes right after the keyword static. And that applies just to that method. So it doesn't get the one from the class if the class has one. It gets the one from the static, right? And so we can do this any number of ways here. I showed there's a couple of different variations on how I can do this, but the idea is producer extends consumer super. So the idea is it wants to copy from one class to another. And that's okay, so long as the class that I'm copying from is a subclass of the class I'm copying to. And there's three ways I can state that, right? I can either say question mark extends T here, or I can say question mark super T here, or I can put both things. Any of those ways it'll work, right? Got that? Then with foo, so the interesting thing about foo is While I can put question mark clauses inside the angle brackets on the right-hand side, I can't put things like T extends on the right-hand side with an angle bracket T. It doesn't parse that. But I can do it on the one right next to the static. I can put that stuff there. And in this case, what I've done with foo is I've said T extends comparable question mark super T. And the reason that I did that is because this allows me to use foo both on the class named foo and on the class named boo. Sorry, Scott. So on the class foo and the class boo, I can use it in both. If I didn't have the question mark super T, then I couldn't use it on boo because boo does not implement comparable boo, right? It relies on foo and the comparator in foo. And so the screwy thing is I can do instance of checks like this. I can say data instance of list integer, and that's okay because it can check the angle bracket part at compile time. I can't say if data instance of list number because that will fail at compile time because it's not a list number. It'll only check the list at runtime, but it'll check the angle brackets at compile time. So it's kind of doing both things, and it's slightly confusing, or maybe very confusing. You tell me, but it depends on you, I guess. All right. And then there's one final thing to note, and that is, bless you. Bless you. List test. Okay, and that is because things are by erasure, I can't overload, say, min generic list integer and I can't overload min generic list integer and min generic list string. I have to have a different method name, right? I can't overload it and give them both the same name and just have the compiler figure it out because of erasure, right? Because the system doesn't actually know the difference. All right, and that's sort of a quick summary of everything generic. Did you get all that? Yes, Vanik.
Can you go over the last part you said about erasure again?
Yeah, so what happens is because of erasure, right? You can't do because it only knows the types at compile time, and it doesn't know at link time or runtime or anything like that. You can't have two static methods, say. You can't have two methods that have the same name, but differ only by the thing in the angle brackets, in the arguments, right? So if I have test that takes a string and test that takes an integer, those two the compiler can distinguish. And it can distinguish it also from a list of integer, but it can't distinguish list of integer and list of string because it can't use the angle brackets to make the distinction. Right? As far as it knows, everything, as far as it's concerned, anything inside an angle bracket is just a question mark for this purpose. So you can't overload it. All right. Any other questions? Yes. Yeah, hash code. Okay, so the basic concept of a hash code is it's a quick way to distinguish things, right? And the example that I love to use is the library. The hash code is your first three letters of your author's last name in the Dewey Decimal System, right? So you can find the shelf. Right away, you can walk into the library and find the shelf that your book is on. You don't have to go through every book in the library. On the other hand, that first three letters doesn't get you all the way there. It gets you most of the way there. And that's what a hash code is supposed to do. It's supposed to get you most of the way there. And so hash code has to be an integer. So whatever complex data type you have to pull an integer out of it somehow and then feed that back. Now, whatever your whenever you're using a hash code, what you're using it in is a hash set or a hash map. And because of that, your hash code shouldn't vary. And in fact, whatever that object is you're using as a key into that set or map should be immutable. It shouldn't change. Bless you. Now, Java doesn't have a way of specifying a class that can't be changed, right? There's no, like you can in C++, for example. But what you can do, right, is you can make the data inside the class private, and then you can offer no methods that mutate that data, and it will stay constant. Any questions about that? That makes sense? Is that, you want more than that? All right, so the idea is, here's another thing that you can say about hash codes. If two hash codes are equal, then the two objects might be equal. But if they're different, then the objects are definitely different, right? If you've got you won't get to the wrong, you won't, if they're different, that means they're on different shelves in the library, right? And and the number is supposed to take me to the right shelf. So if you think about it that way, you won't go wrong. All right. Another question. Unless, of course, you've all perfectly understood everything I presented, which would make sense because it's been very clear. Yes, JJ.
Can you go over like matches?
Yeah, I can do that. So where did I put that stuff? Actually, I could just use the one in the generics. All right, let me just use the one in the generics. So so first of all, let's look at my array map, or generic array map. Okay, so the generic array map isn't really going to make use of the hash code at all, right? It's just going to keep a list of generic map entries, right? And the generic map entry is just a key and a value. Okay, the key is final, the value isn't. I put the key final because I'm not supposed to change it. If I change it, I could mess up my map or my set. And then I have a constructor. Now, one other point about the generics is that the constructor does not get the angle brackets. It's like the only thing that is the exception to the rule that you put the angle brackets on everything. The exception to that is the constructor, right? You don't put it there. Anyway, okay. Back to our regularly scheduled broadcast. All right, so the array maps. So inside here, I'm going to keep a list of these generic map entries. And when I want to do a put, I'm just going to use an enhanced for loop. I'm going to walk through every one of these entries. I'm going to check to see if the entry.k.equals k is true. And if it is, I'm going to update the value and return. And if I go through that loop and I don't manage to update anything, then I'm going to add a new generic map entry to my list of entries, right? There's no sorting, there's no complexity. It's just order n operation, right? Very simple. Make sense? And you can't have a hash map or a hash set unless unless you have an equals method. That is the one thing that is required. Now, right here we have a set. We have a map. Now I could make it a set by simply not having a value, right? If I don't have a value at all on this thing, then it could be a set. And I could do something like I could take a map and I could just always put 1 in for the value and it would be a set, right? So the difference there is just that. Okay, so here's my get method. And my get method is also dead simple, right? I go through the loop. If the keys are equal, I return the value. Otherwise, I return null. If I want the size, I return the entries.size. And I'm not going to go through the iterator right now because this is the basics of the map are that get, put, size, right? And if I want a hash map instead of an array map, the difference is the generic hash map essentially has a list of buckets instead of a list of entries. And each bucket is essentially a generic array map, right? And so that's the way I coded this one. So we have a list of generic array maps that's called the bucket list. And here I have my constructors. I am by default constructing my hash map to have 25 buckets. But if I put a number to this constructor, it will pick a different number of buckets to have. I have a hash to index function. And what that's going to do is it's going to take the hash code that comes from the key, and it's going to remap it to a value that is a valid index into my list of buckets, right? So first it will get rid of the negative sign with an absolute value, and then it will use a modulus operator to bring it into the correct range. And once I have that, I can first, my put method looks like this. I can get my index from the hash to index function. I get my bucket by using the index on my bucket list. And then I call bucket.put, right? So it's as simple as that. And the get method, the first two lines are the same. The third method is bucket.get instead of bucket.put. It's the same. But if I want to do the size, I have to add up the size of all the buckets. So that's a little more complicated. I could keep track of the size independently if I wanted to. Yes.
Is there one thing that's different between is that it can sort extra values?
The difference is the buckets, if that's what you're trying to say. The difference is the buckets. All right. So that's the basics of that. Anybody have a question? Okay. Yes.
Why is this is for constant?
So we don't. I never gave you a time complexity for hash maps. The idea is if I have a really big hash map, right, then it's going to be it's going to be really fast because it will, immediately cut down by a factor, which is the size of the map in the search space. But that would still leave something of order n potentially. So we don't. I have never asked you questions about the time complexity of a hash map. It should be fast, but it'll be fast because the coefficient in front of the n is small, and people like to use it for that reason. But because it's always going to go into because it's always essentially going to go into an array map, you could say it's order n, right? I could say that anytime you go to look up a book in the library, I could say that your search time is going to be, order n. Well, you'd say it's the size of the bookshelf because in the library you've specifically arranged everything to an n that's the size of the bookshelf, which is hard to do in real life with a hash map. But it's just a bit more. It's just a bit subtle and complicated, and so I don't ask that one.
An array map, that's
Yes. Because in principle, you have to go through the whole list every time, or half the list on average.
the key doesn't point to a spot.
The key doesn't point to the spot. That's the difference. So the difference between a generic array map, right, and an ordinary array, right, is that an array, you get an integer, it allows you to jump directly to that value, and all the values are filled in from 0 to n-1. Right? Whereas a map, you can't jump immediately to the value, and the values aren't all filled in, right? If I do a map that goes integer to integer, right, there could be 3 things in the map, and those 3 things could be, -5, 10, and 1,000,000, right? So those are the differences. But the generic map, right, is more generally useful, right? I mean, if you can use an array will be faster. But you can't always use an array. And especially if you're looking things up by somebody's name, right? Then you have to use a string to look it up. And a map is your go-to there. Next question. We've done lots of things in this class. We've done recursion. Yes. I can't hear you. Yeah, I can go over quick sort again. I guess it's 2 that I want. Okay, so my quick sorter 2, right, is, and a quick sort is going to be order n log n. And the reason it's going to be order n log n is the same reason that that a merge sort is going to be order n log n, right? Because essentially, yes. Oh, you want the generic sort? Oh, okay. Let's see. Let me go to my slides for that because I can't remember where I put it. Okay. So so I have a partition function. So this particular quicksort was written as it was written as a stat, using static methods. And in this case, I need to use a partition function. And that partition function needs comparable keys, right? The partition function is what's going to do the actual compare to operations. And because that partition function needs a comparable key, I have to have that, well, it's not a key really. Because its element is comparable, I need that element to be comparable on the sort method itself and on the partition, right? So T extends comparable T. And I can say T square bracket items. That's fair. I'm allowed to do that. What I can't say is new T square bracket, right? That's the thing I'm not allowed to do. Anyway, so T square bracket items, I have a start and an end. If the n minus start is less than 2, I return. I pick a random pivot. If I'm checking to see if the pivot index is valid for some reason, I guess you don't need to do that. Pivot value, you just extract the pivot in the item, from your list of items, you get the pivot index, and then you're going to do a partition. Now, the way I've partitioned it here, I'm partitioning on less than the pivot value, and then on less than or equal to the partition value, right? And so the result of the first partitioning is I get I1, and I1 is going to point to the end of the partition. And so when I do the second partitioning, I can start from there. Because the first one I'm partitioning less than and greater than or equal to, and the second time I'm taking that second piece and I'm partitioning equal to and greater than. Okay, you with me, Serene? All right, and then the partition function itself is where the comparisons actually happen. And what I'm going to do, as always, is I'm going to take an I2 at the start, I1 at the start, and I2 at n minus 1. And I'm going to compare both of those things to the pivot value, right? And if V start is less than the comparison, if it's where it's supposed to be already on the left-hand side, then I'm just going to advance that left-hand side index. And if that's not true, then I'm going to look at the far end. And if that far end is greater than or if that far end belongs on the right, if that belongs on that right end, then I'm just going to decrement that index. And if neither of those things are pointing to where they're supposed to be, if the one at the start is pointing to something that's supposed to be on the right, and the one at the end is pointing to something that's supposed to be on the left, then I swap them. And as long as the I1 is less than or equal to I2, I keep that loop going. All right, and that's how the partition works. But But the only thing that really makes this one special as far as a compared to a non-generic sort is this little goober stuck on the front of, right after the static. Goober is a technical Java term. It means a bunch of horrible looking text. No, it looks vaguely cryptic. When you have angle brackets and T's and whatnot. That's all I'm saying. All right. Yes, Drew.
Can you explain not the partition?
The part that calls the partition method, the main sort method. So the way the main sort method is going to work, right? In big picture view of the main sort method is we're going to pick an element at random, right? If you want to picture sorting a deck of cards, let's say you pull out a card at random, you turn it over, right? Now you sort the cards into two piles. On the left-hand side, you put the things that are smaller than that card that you pulled out, and on the right-hand side, you put things greater than or equal. And then you'd go over to that pile that's greater than or equal to, and you sort it between equal and greater. All right. And then you apply that same procedure to the pile that's less than and to the pile that's greater than. Right. And it's recursive. So each time, in theory, you're cutting down the number of things you need to search by a factor of 2. Right. And so when you cut down things by a factor of 2 every time, how many times can you do that if you have n things? Log n times. So I have log n times that I'm going to recurse, right? And on each level of that recursion, I'm going to go over the whole list, right? Because when I do the division in the first pile, I'm going to have to sort the first and second piles, right? So I'm going to go over the whole array, and I'm going to do it log n times. So the time complexity of a quick sort is n log n. And if you can, somebody asked me, how do you memorize all the different time complexities? And my answer is you shouldn't be memorizing the time complexities. You should understand them, right? And if you understand them, then they'll be in your mind when you need them. And the other thing is with the time complexities, if you're in computer science and you're actually going to do things for a living, you're going to write your own algorithms, and you're going to need to know what the time complexity is of what you wrote. And if you don't understand where these time complexities come from, you're just going to not know, right? And that's not going to work for you. So you shouldn't be memorizing these. You should be understanding them, if that makes sense to you. And if you don't understand them, then you should ask why they're what they are. Yes. Where would you go wrong? Well, so a wild card, so a question mark by itself is not comparable, right? I mean, I could say question mark extends comparable. So for example, when I'm doing this sort, I need T extends comparable T. I need to have a type that I can reuse. I need that T elsewhere. If I put a question mark there, I don't know how to reuse that thing, right? It doesn't have a name. So a question mark is just sort of like anything, but it doesn't have a name, right? And T, if I put a generic T there, T is a name that I can use and reuse. So if that's what you're asking. Does that make sense? All right. It's one of these things that's not going to make sense until you write programs with it, not complete sense anyway. So anyway, it's 10:04. I really should get started with the quiz. So I'm going to shut this down and pass out the quiz.